Okay, everyone. Let me just introduce somebody very, very special to this program. This program is enabled through a Space Act agreement between NASA and a company called NanoRacks. NanoRacks is our strategic partner on SSEP. And NanoRacks was the vision of Jeffrey Manber, who's standing right here. His title is Managing Director of NanoRacks, but you're the head honcho at NanoRacks. And the idea for Space for Everyone is in keeping with the era of commercial spaceflight. So everything that we are doing together to inspire the next generation of scientists and engineers is enabled by him and his company and his vision. So let's thank Jeff Manber for making that possible, and let's listen to some really cool stuff on orbit.
Thank you. It's great. It's great. Thank you, Dr. Jeff, and it's great to be here, and it's great to see everybody so passionate on space. As Dr. Jeff said, we started NanoRacks because it's really, really, really difficult to do space. I mean, you guys probably know this now. Every aspect of space is difficult, from getting the rockets, from doing the paperwork, from the documentation, from all that stuff. That's what we do at NanoRacks, and we try and make it easy. Like when you go, to the post office and you give them your package, you don't think about all the things going on behind the scenes to have it arrive, or you don't think when you do an email what it takes to have that email sent immediately. And so at NanoRacks, we try and make your dreams and your projects in space happen, and we're really excited to be part of this. This is one of the reasons we created the company. Today, I thought I'd do something a little different and talk about, what do we do in space? What are some of the cool things that we can do in space? And so we came up with, myself and some of the guys came up with, and I mean that in a generic sense, and two are here, Kat and Abby are here from NanoRacks. If you want to just raise your hands. Those are two of the guys, okay? And we came up with 7 cool things to do on the International Space Station. So next slide, please. And I mean, the first thing is, I think you all understand, space is different. Okay, and it's up, yeah, you guys got it. Space is different. There's no gravity, it's microgravity. The environment is different. And we just finished a project that was very, very cool. We did a project with the Germans looking at thyroid cancer. And they found out that there's a certain type of cancer in the throat that responds to treatments in zero gravity, but it doesn't respond to treatment on the Earth. Now, why is that? I mean, why is it that in zero gravity, an enzyme responds or a bacteria responds and you can kill it, but you can't on the Earth? And that's what the doctors are trying to figure out. But we flew that experiment just a couple of months ago, and they're trying to analyze the results. And NanoRacks, like with your projects, we don't do the projects, we just make them happen. Next slide. So this to me is one of the coolest things that they're doing in space. There's a huge piece of hardware. This is a research spectrometer, it's called, that's gigantic. It was taken up on the shuttle mission, and it's trying to discover the farthest reaches of the universe. And we're doing that from the space station. We're not in NanoRacks, we're not involved in this, but this is just, to me, way cool. And you can use it as one of the messages I want to give you today is the space station, you can use it for medical, you can use it for astronomy. It's a place, and it's a big laboratory, and you're only limited by your imagination. Next slide. And there's a lot of work going on to study, like astronauts have spent years studying flames in space, in zero gravity. Now that sounds silly, but a flame behaves differently. On the ground, of course, a flame goes up. In space, without gravity, a flame looks different. I guess we should have put a picture in that for next time. But and so you can learn a lot about the properties of fire, about combustion, about how fluids react, and we're hoping that that will lead to much better products both on the ground and as we go on to Moon and Mars. And one of the other points, so point number 1 on the space station is it's difficult to get there. Point number 2 on the space station is you can do it for lots of things. You can do it for astronomy, you can do it for basic science. Point number 3 is that it's not only about products that help us on the ground, it's also about preparing the way for us to go to the moon and Mars, and the other planets. And you guys are young enough, the students here, that what you're doing with Dr. Jeff and everything you're doing may well pave the way for us understanding stuff better that helps our astronauts and helps our everyday people when they get to Mars. So that's very cool to us. Next slide. Material science. This is something, first off, I love this picture. We think this picture is cool. This is 2 little satellites that are coming out of the NanoRacks dispenser on the space station. Those satellites are about this big, okay? They're very small. It's from a company called Planet Labs, and they have cameras. And it's looking down at the Earth to understand erosion, changes in the natural environment. And here you have a private company that's spending its own money, working with NanoRacks, a private company spending its own money and deploying things for the station. So now you're seeing there are lots and lots of different things that we do from the space station. And where the commercial pathway, you have NASA, of course, which is government, and you have companies like NanoRacks and Planet Labs, which are using it for commercial. One of the things we're doing that's very exciting on the station is NanoRacks is involved in working with drug companies, pharmaceutical companies, to look at new medicines. And again, this is really strange about microgravity, but pharmaceutical drugs, the crystals, grow differently in zero gravity than they do on the Earth. And there's about 200 crystals that we just cannot artificially grow on the Earth. And we're thinking, not we alone, but major pharmaceutical companies are thinking that if we could grow these crystals in space, you'd have better drugs. We know we would have better drugs for when you get sick. And so here's an example that we're trying to use the station environment. We're using the astronauts. NanoRacks is providing the research hardware to try and come up with better drugs. And so that's one of the coolest things we're doing. It doesn't lead to fancy pictures, but if it leads to better, medicine, we're all happy. Also ceramics, we can make different materials. Different composites, like the planes today. When you fly, maybe you guys flew here, and if you ever look out the window, you see like the wings bend now. I mean, that doesn't make me happy, but the wings go like this. That's because it's made of composites, and it's flexible, and it just, for those of us who are older, we remember when wings were like, made me happier. Wings was just rigid. Now they got these very cool materials that are so strong, and they bend. And on the space station, we're coming up with new generation composites that you just cannot do research on in the gravity on Earth. And I'm sure before you began working with Dr. Jeff and everything, you never thought about it. Just like a fish doesn't think about the ocean. Fish doesn't think about it's in water. We don't think about the fact that we're in gravity. And so what's really cool, we're like fish coming out of water here. When we work on the space station, we can do all sorts of things differently than we can on planet Earth. Next slide. And also, one of the very cool things that some of you guys are doing in some ways and other researchers are doing is looking at fluids. And as you know from your work with Dr. Jeff, fluids behave differently. And on the space station, the classic example, if you ever have a salad and oil and vinegar, they don't mix. Where in space, they do mix. In space, oil and vinegar, if you go home, get your mom and dad to let you take oil, take vinegar, you put it in a glass, and you get little bubbles. They don't mix on the plate. Yeah, try it. You'll see. It doesn't. I saw the look on you. I saw the look. Okay, it doesn't mix. But in space, when you put oil and vinegar together, and you shake it in a tube, it mixes. And this is really the foundation for what Dr. Jeff is doing, is that in space, fluids behave differently. And again, you learn things. When something behaves differently, you learn. And that's why we're doing so much research on the station, because things don't work the way they do on planet Earth. We're also working on polymers. NanoRacks supplies a lot of the hardware, the mix sticks that, I forget what you call it now, but the little tubes that you guys work with, we supply those tubes. It's again, space is not easy, it's very difficult, but we supply a lot of the hardware for commercial research, for commercial education, and there's just so much that that you're just at the tipping point of so much that can happen by working in space. And let me say, this is the first time we've had a space station. Okay, I guess I take that for granted, and I need to say that. Before, we used to, I mean, you've been through the museum, we used to send people to space via the shuttle. And the shuttle was wonderful, but it went up for 2 weeks, and it came down. And, you know, it's just like a home. I mean, you don't really get settled in 2 weeks. You really can't do good research in 2 weeks, okay? And so now we have the International Space Station, and I don't like when they call it the International Space Station. That sounds like an airport to me, or a bus station, you know, a bus stop, International Space Station. It's a home. And people live there. People live there from different countries, different cultures, different researchers, different jobs, and it's our first real international home in space. And so we're able to do a lot of this cool stuff I'm talking about because some of these projects take 4 months. Some of these projects take 6 months. The work that you do with Dr. Jeff, can go on and off a week, 2 weeks, 3 weeks. You couldn't do that on the shuttle. So all of you are at the very beginning of a new chapter. You're at the very beginning of something new. And that is, one, you don't have to be a professional scientist to do something in space. And that to me is so awesome. I mean, that is just fantastic because I believe, like in software, that you guys are younger than the professionals, but I'll bet that some of you come up with really wicked, really cool things to do. And I'm betting on you, and I'm betting on you with my company as well. And so we believe that as more of you get involved in space, the more that you do in space, you'll come up with great discoveries. We believe in you. And so you're at the beginning of something very exciting. Next slide. I think this is the last slide. Oh, no, this is cool. Atomic clocks in space. This is way cool. They are putting up these clocks that are atomic clocks. They are clocks that are so accurate. And they're measuring time when it's on the space station versus when it's on the Earth, and they're trying to test our understanding of time itself. To me, that's so cool. You don't get up this morning and say, is this really time? What is time? How accurate is this time? When your parents tell you to go to bed, you can say, well, is it accurate? Wait a second. I want an atomic clock because I got 12 more seconds. So they're measuring on the station and in space really accurate time to understand more about time itself. And I think that's about next slide. And so anyway, I just want to, thank you guys. We're so happy to be working with the schools. We believe in you passionately. We don't even think you're the next generation of scientists. You are scientists. When you're working with Dr. Jeff, what you're doing is real research. And a lot of people are counting on you. At NanoRacks, we'll do our best to do it as much as we can. And we're really, really happy to be working. You're part of a small group. Very few students, very few human beings have done work in space. And so you're very, very lucky to be part of this. I hope some of you go on and go into the field of space research, but I know all of you will take away appreciation that we live on the planet Earth. It's a special place. It has gravity, it has air, and all around us are places that don't. And I hope you visit. If you don't make it your work, at least you visit. And that's it. So thank you very much.
I wanted to say a couple of things here. The first thing is that there is this national SSEP team, and I'll do a more formal thank you tomorrow. But on the NCESSE side, we've got Stacy and John and Tim and Mike and Harry and Matt and Drew. And on the Air and Space Museum side, we have Mike and Paul and Mark and folks downstairs. NanoRacks, you've got an incredible team at NanoRacks, and all of these folks are working together to make this possible. It's a real sort of like a family affair.
Space is difficult. And Jeff is right, it takes all of us working together. Space is very, very difficult.
So we actually, Jeff, I thought of a nice thank you to you because we're with you. We understand the vision, and we started this conference off this morning with an understanding that we are all blazing a trail through history in commercial space. And you weren't here this morning, so I'm going to ask them to do it again as a thank you to you. Could all of the principal investigators, co-investigators, and collaborators please stand?
This is great. Get a picture,
This is
get a
what
picture,
you
get a
are
picture.
enabling.
Great. That is so cool. Well, let me applaud you guys. That's really good. Thank you. Yeah, that's great.
Okay, so we're supposed to be stopping here at 12:30, and we will. We probably have time for 1 or 2 questions at most. Does anybody have any questions for Jeff?
Now, come on, guys. You got to have a question.
I know sometimes it's pulling teeth this morning.
Yeah. No questions?
We have one. First name and where you're from.
Hi, I'm Julie. I'm from Memphis, Tennessee,
Hey, Julie.
or Somerville, small town outside. Space is difficult, so my question, question to you is, do you guys have facilities here that can simulate laboratories to do research here on Earth that you can do there as well?
What a great question. We have facilities. Our major shop is in Houston, Texas, because the gateway to space is through NASA's Johnson Space Center. And the rockets are launched from Kennedy. Some of the rockets are launched from Virginia. But the way that you get to the space station is through the Johnson Space Center in Houston, Texas. And so we have a big shop. We're about 35 people, still small, but a big shop in Houston. There's about 6 of us in Washington. So in Houston, we have the hardware on the ground. You're right. And you can come, or, you know, Dr. Jeff has come, or we do it long distance, and play with the hardware and work with the hardware. And we work with the astronauts. You would not believe how hard. We work with Marshall Space Flight Center in Alabama to figure out to make sure the hardware works, when the astronauts will touch it. It's not something like, oh, let me just do something today for Dr. Jeff. Okay, it's mapped out months in advance when the astronauts will touch the hardware. They've already seen a video. We make a video of it, and we work with the astronauts on the ground, and then when they go up to space. And so everything, as much as possible, is pre-planned. So you're right. Good question.
Hi, I'm Christina Murray from Downingtown, Pennsylvania. I was just wondering, like, what career paths would you have to follow, or what areas of study would you need to go into if you wanted to work in NanoRacks or send something up in any of your products to kind of study or
Another great question, because everything I was showing here is research. But in NanoRacks, we really don't need researchers. If you want to work in NanoRacks, you need to be an engineer, okay, because you're working with hardware. And so if you become a mechanical engineer, it can be very cool, electrical engineer. So, you know, you take your math, you take your physics, and you really have to learn. And the guys who work in Houston, you know, they know how material works on the Earth versus works on the moon and works in space, even how you connect things together, and the electrical currents are different in space. So really the pathway to work with us would be engineering.
Thank you.
Thank you. Good luck.
Now let's thank Jeff again.
Thank you.